What if you could automate time-consuming business processes to improve efficiency? What if predictive algorithms could learn to make better decisions than humans? Welcome back to ARCROTGIS Technology College. In this video, we'll explore how technologies like data science, data engineering, and DevOps are making this a reality for companies today. Let's get started. First up, data science. As you probably know, data science applies techniques like machine learning to make predictions and optimize decisions based on data. This allows businesses to automate processes that previously required human intuition, planning, and intervention. For example, predictive analytics uses data science models to forecast metrics like future sales, website traffic, and customer churn. Instead of analysts manually building projections in spreadsheets, models can automatically analyze new data as it arrives to generate rolling forecasts. This enables way more adaptive and dynamic planning and resource allocation. Recommendation engines are another example. Services like Amazon and Netflix use various data science algorithms to analyze user behavior and preferences. They then automatically recommend products, content, and promotions tailored to each customer. This level of personalization at scale was impossible for human marketers to achieve manually. In manufacturing, computer vision techniques can automatically inspect products coming off assembly lines for any defects or quality issues by analyzing image data. This eliminates the need for manual human inspection, which is slow and prone to overlooking flaws. Chatbots and virtual agents also rely on data science, specifically natural language processing and deep learning, to understand and respond to customer service queries without human agents. Translation services like Google Translate apply similar NLP techniques to instantly translate text, audio, and video data between thousands of language pairs. As you can see, data science allows businesses to automate a diverse array of predictive tasks and subjective decision-making processes previously requiring human intervention. This enables huge efficiency gains and frees up employee time for higher-value creative and strategic work. On the technical side, popular data science tools used for automation include languages like Python and R, libraries like TensorFlow and PyTorch, and cloud-based platforms like AWS SageMaker and Microsoft Azure Machine Learning. Now let's discuss data engineering. While data science focuses on extracting insights and predictions from data, data engineering deals with building the pipelines for collecting, storing, and transforming data at scale. This backbone is crucial for fueling the data science and analytics applications we just discussed. For example, ETL, extract, transform, load pipelines automatically pull data from sources like databases and APIs, process and convert it into the needed formats, then load it into destinations like data warehouses and lakes. This happens continuously without manual intervention. Stream processing frameworks like Apache Kafka and Flink allow endless streams of real-time data from sensors, web traffic, IoT devices, and other sources to be continuously ingested, processed, and analyzed. This enables use cases like fraud detection and predictive maintenance, which require automated handling of high-velocity data. Workflow management tools like Apache Airflow schedule and orchestrate data processing jobs across these pipelines. They monitor workflow steps and trigger alerts or remedial actions if failures occur. This automation ensures pipelines run smoothly without constant manual oversight. Finally, cloud data warehouse services like Snowflake, BigQuery, and Amazon Redshift provide the backend for scalable managed data lakes. Companies can leverage their flexible storage architecture and scale resources up or down automatically based on demand. This removes the burden of manual data warehouse administration. Some popular technologies data engineers rely on include big data frameworks like Hadoop and Spark, streaming platforms like Kafka, workflow managers like Airflow, transformation tools like dbt, and cloud data services like AWS, GCP, and Azure. The third domain we'll explore is DevOps, the combination of software development and IT operations practices. There are a few ways DevOps introduces automation. Continuous integration tools automatically build code changes made by developers multiple times per day and run tests to detect bugs early. Without CI, validating code changes is manual and slowed by release schedules. Continuous delivery pipelines automate deploying validated code changes into production environments. Automating releases decreases downtime during new deployments and accelerates delivery of new features. Infrastructure as code tools like Terraform and Ansible let engineers define desired infrastructure like servers and networks in template files and automatically spin them up on demand. This replaces manual configuration, which doesn't scale. Monitoring tools continuously collect metrics and log data from systems, detect anomalies, and can automatically trigger alerts and remediation. Humans can't watch everything in production at all times. Taken together, these DevOps practices introduce automation across the entire software development lifecycle. From code, build, test, release, to infrastructure management and monitoring, this increases velocity, reliability, and scalability compared to traditional manual IT processes. Some popular DevOps tools enabling automation include version control systems like Git, CI, or CD tools like Jenkins and Spinnaker, infrastructure provisioning tools like Terraform and Ansible, monitoring stacks like Prometheus and Grafana, and container orchestrators like Kubernetes. Bringing it all together. We've looked at how data engineering, data science, and DevOps each contribute automation capabilities in their respective domains. But how do they work together in practice? Fundamentally, data engineering infrastructure and pipelines supply the data feeding into data science applications. The predictive models and analytics output by data science are then operationalized and deployed, leveraging DevOps tooling and practices. For example, let's look at a company building a real-time recommendation system. Building an effective real-time recommendation system requires a cross-functional effort. Data engineers construct streaming pipelines to ingest user behaviors. Data scientists develop models analyzing that data to generate personalized product recommendations. DevOps pipelines continually retrain the models on new data and release updated versions to production. When these teams collaborate, companies create robust systems that engage users and drive business value. This integrated approach also creates a feedback loop. As models run in production, performance data triggers retraining and redeployment of newer, better versions. Now that we've discussed these technologies conceptually, let's briefly run through some of the most popular tools used by organizations in each domain day to day. Organizations rely on a vast array of technologies to bring together data science, data engineering, and DevOps. For example, data scientists may leverage Python for analysis, notebooks like Jupyter for development, and tools like MLflow to productionize models. Data engineers employ workflow schedulers like Airflow to automate pipelines, distributed systems like Spark for big data processing, and cloud platforms for managed data services. DevOps engineers use version control with Git, CI, or CD tools like Jenkins, containers and orchestrators like Kubernetes, infrastructure as code tools, and monitoring solutions. With so many components involved, it's crucial that teams holistically view how these pieces fit together end-to-end to deliver business value. Taking this system perspective allows organizations to thoughtfully select and integrate the right tools for their needs and build a cohesive, data-driven ecosystem. Of course, companies build out their stacks with different tools based on their infrastructure, budget, and in-house expertise. But hopefully this gives you an idea of the rich open source and cloud-based ecosystems available across these domains. What automation tools and technologies are you using in your organization? What business processes have you helped automate in your role? Let me know in the comments section which ones you found most valuable. And hit like and subscribe button to ARCROTGIS Technology College to get more valuable information about data science, data engineering, DevOps, and more automation topics.